Hi everyone, this video will take us through the last steps of having our controller code up and running. So to start with, you should have a couple libraries installed, one for the SPI and one for the NRF Lite library. This is a library that's going to do the majority of the work to make the radio transceiver work for us. You should also have these variables in already. There's a channel, a radio ID variable. So you can think of the channel variable as being like the frequency of a radio station, like 106.9, that's the channel it's on. Make sure that your controller and hovercraft are on the same channel so they can communicate and that no one else is using your channel. We've got lots of channels, anywhere from 0 to 125 are all the different channels we can use. So make sure you're choosing one that no one else is using. Radio ID is the ID number of the transceiver that's on the controller. So this little device, find it? This little device is the transceiver, and you're going to give it a unique ID number. I don't know what the max is. Let's say it needs to be under 100. I'm not sure what the number is. I'm going to use 0 and 1 for mine. What the program's going to do then is send that ID number to this transceiver in the controller. You'll have another one in the hovercraft. It will need a different ID number. That way this one can say, hey, it's me, number 1. I'm talking to you, number 0. And then 0 can say, oh, hey, yeah, it's me, 0. Hey, number 1, here's some message for you. So those are the two ID numbers we need. The first number is the one in the controller in this case, and then the next one is the destination where it's going to be sending to, and that's going to be another different number. These numbers can be the same as other groups because they will be on different channels, so you won't have a miscommunication. The last two things here are just pin radio, where you put the CE pin and the CS pin. 9 and 10 should be where those are plugged in at. All right. Now you might be wondering, well, what's going on with all of this crazy stuff in front of the variable name? Channel is the variable name, and normally to make a variable, we just do INT. Well, let me walk you through that real quick. If you notice there is an INT right here, that is the same INT as that we normally use for an integer variable. But the makers of this library have gone to a little extra effort to make the library compact and not use very much processing space. That way there's more memory and more processing power for your program and not their library. To do that, they first started by putting a U in front of the INT. That means unsigned, which means this number here can't be a negative number. It won't allow it, which is fine because all of our channels are positive numbers, so we don't need it to be a negative number. This part after the INT, this 8_T, tells Arduino, hey, this is going to be a really small number. We're going to store it as what's called an 8-bit number. An 8-bit tells it how many little pieces of memory to set aside. In this case, it's going to set aside 8 of them for this number. That gives you a maximum value of 255, which is perfect because our max values end at 125, so we don't need more than that. A normal INT variable will set aside 32 bits of memory to store that information, and even if it doesn't need it, it's still going to set aside that full 32 bits. So this will make the variable smaller and use up less memory. Yay for us. And the last two things are this const and static. So const is short for constant. That means that once you make this variable, you can't later on in your program set it to something new. It's stuck at whatever you make it at first. And static has to do with how many times the variable is created throughout the program. Static means, hey, the first time it's created, don't ever delete it, just leave it alone and don't ever recreate it. Just make it once for the entire program. Oftentimes variables are created, deleted, and created again over and over again every time they're used. In this case, with the static command, it won't. It frees up a little bit of the processor of the Arduino to do the work we want to do and not do the library's work. All right, so that was not super important for you to know, but I thought it would be interesting to know what all of this craziness out in front of the variable name is, and to know that it's just a regular old variable. These are the variables that the library told us we needed to include to make the library work. So without these variables, the library won't be able to do its job. All right, the next ones, these next variables are the ones I created to be storing the values in from the joystick, the X and Y of the joystick, and the potentiometer. You probably use different named variables. Don't change them to my names, use your names. Just know my code's gonna have this reference to it. The next thing is another thing from the NRF library. We have to have this. It creates a structure called radio packet. This lets us create radio packets, like packets of data to be sent by the transceiver. So don't worry about what it does or how it does it. We just need to have it in order to make it work. The one thing that we do notice here that we can send 32 bytes, and that means that we can get 8 different data points into one packet. So if we need more than 8 data points, then we need to have 2 different data packets. That means we can get, the good thing is we only have 3. We have X, Y, and potentiometer, and so we're gonna have plenty of extra room in our data packet. Awesome. The next 2 things create what are called objects. This is saying the library it's using, and it's creating a radio object that we're gonna use later down here. Don't worry about objects that are beyond the scope of this course, but we need these 2 lines, and it creates a radio data, and that's used down here as well. So we need those 2 lines to make the library work. Awesome. If you're like, hey, how did you know to do that magical stuff? The library, when you download it, there's a instruction sheet for it, and it just tells you to include all this stuff. So there's nothing magical about knowing how to do all this stuff. It really is just the library telling you what to do. All right, next thing we did is we create a void setup, and we opened a serial communication, which is something we always do because we want to be able to monitor our program. Then this is a feature for the transceiver. So we create this if statement, and in here is a radio init function. This is from the library, the NRF library. What this does, this function turns the transceiver on, and it runs it through some startup processes to see if it's working or not. If it is not working, if there's an error from the transceiver, this function sends back a 0. So all of this is replaced by a 0, and if 0 is equal to 0, if it comes back as a 0, it's going to do what's inside this if statement, which is this while loop. And because it says while 1 equals 1, well, heck, 1 will always equal 1. So if it goes in this if statement, it's going to get stuck in this while loop, printing out this error message saying, hey, that can't communicate with the radio. Something's wrong with the radio. And it will delay half a second and then print it again and again and again. So if your program's not working and you open up the serial monitor port, and you see this printing over and over again, you'll know that there's something wrong with your radio transceiver. Now, on the other hand, if when this function runs, the radio transceiver sends back a message saying, hey, I'm all good, it's going to send back a 1, and 1 is not equal to 0, so it's going to skip this if statement and do the else statement, which is it sends the radio transceiver, it sends this little device, its radio ID number that you set up here. So it tells the transceiver, hey, your number, whatever you set up there. Awesome? Okay. So that's this whole setup part. We're done with that. All right, so void loop. In here, you should have created some kind of code that looks similar to this, where you're reading an analog pin from the X direction of the joystick, you're storing it in some appropriate variable, doing the same thing for Y and the same thing for the potentiometer. I also put in some serial prints so that I could see them changing on the screen and make sure everything was working just great. If you haven't done the serial prints and checked to make sure that this is all working, my advice to you is pause the video, do that now so that you are ready to rock and roll. You don't want to build more code on top of broken code. You want to fix stuff as you go if you can. Okay, so now let's get to the actual coding of stuff. Well, let's hold off actually. Let's do it in the next video. We'll get to the actual packaging and coding stuff.